Don't forget to subscribe and ring that bell.
Here we go. The fifth and final video for the January 2023 Regents High School examination for Algebra 2. We are going to do problems 33 through 37. They are all short answer, and they are the higher point questions. Let's go get them. First off, okay, numbers 33 through 36 are 4 questions, and they are worth 4 points each. Okay, again, if you use your calculator to get the right answer without showing work, it's still worth 1 point. Okay, so don't throw that point away if you know how to use your calculator. But I'm here to show you how to do it all the way through. Let's go. Okay, these are typically algebra heavy, so, don't expect anything less. Solve the equation, the square root of 49 minus 10x plus 5 equals 2x, and do this algebraically. First and foremost, in order to get rid of the square root, we need to isolate it. So the first thing I'm going to do is subtract 5 from both sides. Boom, square root of 49 minus 10x equals 2x minus 5. All right, now I can get rid of the square root by squaring it. These are cancel. What I do to one side, I have to do to the other. So I have 49 minus 10x equals. I've got to FOIL this. That is 2x minus 5 times 2x minus 5. Okay? This will give me 4x squared minus 10x minus 10x plus 25. The only thing I can combine are these 2 minus 10x's to give me minus 20x. So it's 4x squared minus 20x plus 25. That's going to be the right side here. All right. Now, that is clearly a quadratic. I have an x squared, I have an x. I need to set it equal to 0. So I'm going to subtract 49 from both sides and simultaneously add 10x to both sides. Bye-bye, bye-bye. 0 equals 4x squared minus 10x, and that will be minus 24 if I combine those. Okay? Now, the first thing you should always try and do is factor out a GCF. Okay? So I'm going to divide both sides by 2. Okay, that means 2 is going to go into all these numbers. 0 divided by 2 is still 0. I get 2x squared minus 5x minus 12. All right, I teach my kids slip and slide. What does that mean? Okay, slip and slide is the following. Okay, if I have 2x squared minus 5x minus 12, the 2 I slip to the back and multiply it. So now I've got x squared minus 5x minus 24. Now, I can just factor this like I normally would. It makes it really easy, right? So, here with the gray. 2 numbers that multiply to be negative 24, that add to negative 5. It's negative 8 and positive 3. Now, don't forget, I still have this 2. I multiplied it to the back. I can't just leave it like that. I got to bring it back in by dividing it to the back, but to both backs. And I reduce where I can. This becomes 8 minus 4. This is 4. And if I can't reduce it anymore, even if I could simplify the fraction, if I still have a bottom, I say bottoms up. So this 2 is going to come up front in front of the x. It's 2x plus 3. Okay, and that's what I call slip and slide. Slip to multiply, slide and divide. All right, now, last but not least, let's solve for both of these. Okay, x would equal a positive 4. Okay, and okay, if I have 2x plus 3 equals 0, I subtract 3, get 2x equals negative 3, and I divide by 2. So x would equal negative 2/3. So I have two answers here. But the question is, I have a radical. I need to make sure that both of those answers work. Okay? So I know a positive 4 is going to work. I'm questioning the negative. You should really check both answers. I'm going to erase this here so I could do everything on one screen here. Here we go. If I put negative 3/2 in for my x here and here. Okay, I have the square root of 49 minus 10 times negative 3/2 plus 5. That's the left side. Okay, that's going to be the square root of 49 minus, oh, that's plus, a negative times a negative. That's going to be, oh my God, 15 plus 5. You can check that out yourself in the calculator. In fact, you could type this all in the calculator and hit enter. Okay, you're going to 64, you're going to 8, you're going to get 13. All right, so if I put negative 2/3 here, what will I get? That's going to be 8. Yeah, no, that's going to be, okay, 2 times negative 3/2. That's just negative 3. That does not work. So negative 3/2 is an extraneous solution. Make sure you cross it out. They used to have us label extraneous solutions, but it doesn't look like they're telling you to label it, so you're good to go. As long as you cross it out, you have one answer that works, and it's at 4. All right? By the way, it doesn't tell you to check. So if you wanted to, I could graph this into y1, and I can graph this into y2, and I can see where they intersect. They would only intersect at 4. They would not intersect at negative 3/2. You cannot do that to show work, but you can do that to definitely find which of those might be an extraneous solution, which solution won't work. Okay, number 34 is a little bit of a break after doing all that algebra. Joette is playing a carnival game. I love carnivals. Get the deep fried Oreos. You'll thank me later. Okay. To win a prize, one has to correctly guess which of the 5 equally sized regions a spinner will land on, as shown in the diagram below. She complains that the game is unfair because her favorite number 2 has only been spun once in 10 times she played. State the proportion of 2s that were spun. Not the odds of getting a 2, but the odds of getting a 2 based on the actual results that were spun. 10 times, and it only landed once on 2. So I simply put 1 out of 10. That's my first answer. You're welcome. Okay? The second thing. Now, they're asking me, state the proportion. A proportion, I guess, would be a fraction. We're good. I mean, if you want to put 0.10, I mean, that's a rate. Yeah, you know what? I write them both like that, and I box them because they're the same. Now, below here it says, the simulation output below shows the result of simulating 10 spins of a fair spinner repeated 100 times. This means every dot, this dot here, this dot here, this dot here, this dot here, they all represent 100 spins. This is 100 spins, okay? This is 100 spins, and this is the percent of landing on 2, of winning. This is 100 spins. So that's a lot of data right there, okay? Let's scroll down. It says, does the output, okay? Why do I feel like I'm missing something here? I'm missing something. I'm missing a question. Ready? There it is, right there. All right. Now it's saying, here we go. Now everything's right with the world. The second part says, state the theoretical probability of spinning a 2. That means I don't care what was actually spun. I want the odds of spinning this once and getting a 2. Well, there are 5 numbers, and there's only one number 2. There's one option that I want out of 5. Okay, out of 5 possible outcomes. Okay, and that would be the same as saying 0.20. All right, there you go. Something looked a little off. I figured it out. All right, so now we're down here. Does the output that the carnival game, does the output indicate the carnival game was unfair? So let's take a look at this. Does this say that the carnival game was unfair? So it actually landed, the carnival game that it actually spun. So we're looking at this right here. Is this unfair based on that chart below? That's 10%, correct? So if I look down here, look how many of these landed on 10% of winning on those simulations. All of those simulations in this column here represent, each dot is 100 spins where they landed on 10% of the time. Okay, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And how many dots are there altogether? There's 100 of them. Oh, God, I hate this board sometimes. Okay, so 21 out of the 100 had this same output where they only landed on number 2 10% of the time. Okay? So, is my game unfair? And the answer is no. Okay? This represents 21 out of 100 is 21%. Okay? No. How come? Because per the simulation, 21 out of 100 times or simulation, 21 out of the 100 simulations, I'm going to abbreviate. I'm not going to abbreviate, I'm going to abbreviate. Okay? So 21 out of the 100 simulations had the same outcome of 1 out of 10 or 0.10. Now, that's considered normal. I like to add this in there, okay? 21%. If here's 0% and here's 100%, 95%, the inner 95% is considered normal. Okay, 21% falls within that 95%. So any of these outcomes are normal. This is 21%. This happened 21% of the time. So that's considered normal. So I like to mention that 95% and say the 21%, which is right here, is within normal outcomes in the 95%. Okay, so I mean, sometimes I like to throw that in there as well. But that's it. Okay, we really just got to read that graph and know that, hey, 21% of the time, 21 out of 100, I got the same outcome. That's a common occurrence. That does happen. In fact, it happened 21 times. So yes, it is possible to happen here. And that's not unfair. It is fair. If you don't use your graphing calculator to look up points to plot this, shame on you. Don't even finish watching this video. Just take the L. You're going to fail a test. Graph C of X. They're telling you what to graph, and they give you the graph. Just graph it. My goodness. So I'm going to go here. I'm going to go here. Then I'm going to go turn this on first. That would probably help. I'm going to go to y equals. And I'm going to clear this stuff out. And I'm going to put the equation they give us here. Okay, it is -9 times 3 raised to the x minus 4, pop off the exponent, and then say plus 2. Okay, Now, I am going to graph this. This is on a 10 by 10 screen. This is what it should look like. Okay, when I get done graphing it. If it doesn't look like this, you done messed up there, Henry. Now, okay, I'm going to look at the table. I'm not just going to, please, for the love of God, don't just be like, oh, it looks like it does this. You know, because people do that. It drives me absolutely crazy. You have a set of coordinates. This axis they give you is 10 by 10. It's the same one on the graph here. I'm going to look at my table, and I'm going to start going to negative 10 first. Okay, let's go all the way up. That. I'm going to graph these points, some of these points, okay? Negative 10, I'm at 2. See right here, negative 10. So I got negative 10, I'm at 2. Negative 9 and negative 8 are still at 2, so I go here. I mean, you don't have to plot everyone. I mean, I'm still kind of at 2, almost till negative 1, which is right here on the x-axis. So, I mean, we're really close, just below it. I mean, you want to put something in between just as a kind of a connection dot. There. At 0, I'm at 1.8. So maybe a little bit lower when x is 0. So now let's take a look at my positive x values, 1 through 10. So delete this. Go here, bring this out. I'm just going to scroll this down until I get to positive 10. And then I'm going to here we go. We already have 0. Okay, so let's go at 2. I hit 1. So here's 1, 2. I hit 1. Okay, at 3, I'm at negative 1, which is right down here. Okay, then at 4, I'm at negative 7. It's 1, 2, 3, 4, 5, 6, 7. And then once I hit 5, I'm way off the charts here. So I'm not even going to hit 5 down here. So I'm just going to connect these. Put a little arrowhead here. There you go. And we could say C of x equals negative 9 times 3 to the x minus 4 plus 2. They used to take points off if you didn't label. I don't know. So that's maybe old school of me to put that label on there. But there you go. That's it. That's my graph in all its glory. Describe the end behavior. You have 2 questions here. Describe the end behavior as x approaches a positive infinity. So as x goes to positive infinity, where does C of x go? Up or down? Positive infinity. The x's are positive on the right-hand side. So as I go to the right, is my graph? It goes down, doesn't it? So it would go down to negative infinity on the y-axis. It would go down forever. That I thought was pretty easy. Describe the end behavior as x approaches negative infinity. So as x goes to the negative side, all right, here are the negatives on the x. So as I go to the left forever, what is my y approaching? Notice my y hits 2 and stays at 2 forever on a 2 on the y-axis. So it'll approach 2. It'll never get any higher than 2. If you are like, I'm not sure. If I keep on going more and more negative, let's take a look at the y. Okay, so right now it's a positive x. Let's go to negative 10. See how my y values are approaching 2? Now look, see how it hits 2 and it never changes? As I go to the left forever? See, I'm going more and more negative. Let's do something even crazy, kids. Kids, let's get crazy. Let's go to negative 100. Now let's look at my table. I'm still at 2. I'll never get any higher than 2. So guess what y is going to approach? C of x, just y, will approach 2. Two more problems and we're done with this debacle. All right, 36. Let's move this back here. The monthly high temperature in degrees Fahrenheit in Buffalo, New York can be modeled by B of M. 24.9 sine of 0.5 m minus 2.05 plus 55.25. A lot of points there. Where m is the number of months since January. And January is 1. Okay, m is the number of the month. Where January is 1, February is 2, and so forth. Find the average rate of change in monthly high temperature between June and October to the nearest hundredth. Okay, so first of all, hundredth is 2 decimal places. We're rounding. Don't just cut off. Average rate of change is just slope. It's my change in y over my change in x. So it's y2 minus y1 over x2 minus x1. Okay? But they want this between June and October. June is 6 month, and October is 10. These are my x values. So I'll call this x2 and x1. So on the bottom, I have 10 minus 6. So how do I find the y value when my x is 10? I just plug it into the equation. Minus. How do I find my y value when x is 6? I just plug it into the equation. All right? So 10 minus 6 is going to be 4. Let's figure out what b of 10 minus b of 6 is. All right, and I am going to do this right here now, kids. Let's get out of here. And my equation was 24.9. Sine. Go to mode and make sure you are in radian mode. You should always be in radian mode. Okay? So it's the sine of 0.5 times my m. In the first case, it's 10. Minus 2.0, is that 50 or is, no, it's 0.5, 0.5, close that parenthesis, plus 55.25. Bam. So that's 59.992, whatever. There you go. So we'll call this 59.992 minus. Okay, now I got to do the same thing for 6. Okay, we just did b of 10. We put a 10 in there. Now we got to do the same thing for b of 6 and put that right here. So the only thing I got to do in my calculator is change this 10 to a 6. So I'm going to go up here, highlight it, and hit enter. Then I'm going to scroll back to the 10 and make it a 6. 8, 6, boom. 75.504. 70, oh boy. 75.504. All right, I'm going to subtract them and divide them by 4. So instead of rounding them like I did on the paper, I'm just going to go here. I'm going to highlight this answer, enter, minus this answer, and hit enter. And I got to divide that by 4. Okay, that's the numerator. But I'm just going to divide it by 4. That gives me 3.878. Negative 3.878. But they want it 2 decimal places, so we'll say negative 3.88. There we go. That is the average rate of change. Okay. What does that mean? Oh, the explanations. It's crazy. Well, obviously, it's negative, so my temperature, right? Wasn't my equation the high temperature in degrees Fahrenheit? So my average change in that temperature per month from June to October is a decrease in 3.88 degrees. So the average change in temperature in Buffalo, because that's the city, from June to October was a drop of 3.88 degrees Fahrenheit per month. There you go. That's it. Okay, if you were scared a little bit, here you go. 6 points. This is a 6 point. There is one question. Answer the question. This is the question. 6 points. Let's do it. Don't be scared. Don't be scared. Oh, be scared, kids. I'm kidding. We got this. 37. Objects cool at different rates based on the formula below. I love Newton's law of cooling. That's what this is based on. My temperature, T, okay, equals T of 0, T sub 0, minus T of R times E to the R. Oh my God. So, and then T, there's a T here, plus T of R. Okay? Where T of 0 is the initial temperature. T of R is the room temperature. R is the rate of cooling of the object. And T is the time in minutes for the object cools to a temperature of T. Okay, so let me do this here. This little T has got to move over. Da-da. And it looks like temperature T. That's the final temperature. Okay? We've got everything here. Mark makes t-shirts using a hot press to transfer designs to the shirts. He removes the shirt from the press that heats the shirt to 400 degrees Fahrenheit. The rate of cooling of the shirt is 0.0735, and the room temperature is 75 degrees. Using this information, write the equation for the temperature of the shirt, T, after T minutes. Okay, so I need to write an equation for T, and it should be in T minutes. Okay, so I'm going to have my variable T. This T exponent will still be there. So what do I need? I need my T of 0, the initial temperature. The initial temperature is 400. That's T of 0, 400. That's what it was when it first came out. Minus the room temperature. Okay? The room temperature, the room temp is 75 degrees. That happens in 2 spots here. Okay, and then we have like plus the room temperature out here. That happens in 2 spots, here and here. All right, I've got an E raised to a negative something. We'll get that. And they give us, okay, oh my God, I'll do this in red even though it's supposed to be yellow. Okay, the rate of cooling is this right here. So my R is 0.0735. So negative 0.0735 times T. Don't forget we need that T there. This is my equation. That's it. That's all they ask me to do. If I could read what number goes in for what variable, I'm done. Here's the next best part, children. Okay, so far, this isn't hard. It's complicated because there's a lot of variables, but it's not difficult. Okay, the next thing says, use this equation to find the temperature of the shirt to the nearest degree after 5 minutes. I am just going to put a 5 in for T and then hit enter. So my temperature is going to equal 400 minus 75 times E to the negative 0.0735 times my time, which is 5 minutes, plus 75. Okay, that's going to approximately equal. All right, so I'm just putting that in a calculator. Nothing fancy, kids. Clear this out. We've got parenthesis 400 minus 75 parenthesis E raised to the negative 0.0735 times 5. Pop off the exponent, plus 75. 300.05. That's 300.05. So after 5 minutes, remember, it started at 400. It's now cooled to 300.05. They want it to the nearest degree. That means whole number. 300 degrees Fahrenheit. Okay? 300 degrees Fahrenheit. Here we go. Oh, man, 2 more. At the same time, Mark's friend Janine, ooh, I see some competition. removes a hoodie from a press that heats the hoodie to 450 degrees. And after 8 minutes, the hoodie measured 270 degrees. The room temperature is still 75 degrees. Determine the rate of cooling. So now, oh my God, now I need to find the R. So in this equation up here, now I need to find the R. That means I should have numbers for everything else here. The T in purple, the T sub 0 in blue, the 2T of R's in green, it's the same thing, and my time in orange. Okay, I should have all of those. Okay, so let's go down here. I need to determine my R. So it starts off, my T sub 0 is 450. So I got 450 minus my room temperature. The temperature of the room is still 75. Remember, that happens in 2 places. I'm finding R. Okay, plus my room temperature is still 75. Okay, it took 8 minutes. My time is 8. And it cooled down. The end temperature was 270. Whew! All right, so I'm going to have to solve for an exponent. Log or natural log, I'm going to use natural log, is going to bring that exponent down. But first, in order to do that, I want to get my base and my exponent alone. All right, so let's start doing some opposite math here. Let's subtract 75, subtract 75. Boom. So I've got, oh my God, is that 195? Equals. When I take 450 and subtract 75, I think that gives me 375. E to the negative, when I multiply this, I just call it negative 8R. All right? So right there in that one step, that's not that bad at all, okay? So now I'm going to divide. Again, I want to get the base and the exponent alone. So now let's divide by 375. So that's a bad 5, kids. Okay, let's take 195 and divide it by 375. 0.52, it's nice. It's not a run-on or anything. 0.52 equals e to the negative 8r. Guys, I can't explain this enough. Logs bring down exponents, but I always like to use natural log. And in this case, you absolutely should. I mean, you don't have to, but the exponent comes down. So I've got negative 8r. It's no longer an exponent. ln and e cancel. So I'm doing that times the ln of e. The ln of e is 1. Anything times 1 is itself. So I just go boop. And now I've got the ln of 0.52. All I've got to do to get my r is divide both sides by negative 8. So my r is approximately equal to, okay, in my calculator, I'm going to do the ln of 0.52 and divide that by 8. Got negative, okay? Negative. And I'm sure at some point, kids, they told me to round to the 10,000ths. The 10,000ths is 4 decimal places. Tens, hundreds, thousands, 10,000ths. This will stay as 7 because the number after it is less than 5. Okay? So, negative 0.0817. Well, actually, I got to divide that by negative 8. I divided it by 8. Negative 8. So that'll just be a positive. Yeah, I knew my rate should have been positive. That was weird. So it's positive 0.0817. Okay. Well, that was, I mean, the first one, we just had to put the equation together. Not bad. The second one, we literally put a number in for time and hit enter. This one wasn't, I mean, it wasn't horrible. Okay. Now, let's take a look at the last one. The t-shirt and hoodie were removed at the same time. Determine when the temperatures will be the same to the nearest minute. All right, so Are you ready? The equation for the t-shirt that we came up with was 400 minus 75. This is from the first part. E to the negative 0.0735 times t plus 75. Okay? The equation for the hoodie that we just came up with was t equals, okay, it was 450 minus 75. Okay, e to the negative. Now I have the r here, 0.0817. You might be saying to yourself, Visca, I thought that was positive. It is positive. But let's not forget, I need to negate whatever my r is. Okay? My r should be positive, but when I write it, I need to negate it. So down here, here's my rate. I need to negate it. Times time plus 75. So when will this t equal this t? I just set my equations equal to each other. Okay, I just set my equations equal to each other. Put this in the calculator. It doesn't say to show it algebraically. You just show what you're putting in the calculator. It doesn't say to show your work. Put this graph in the calculator and see where they intersect. Let's go. Boom, 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 boom. So y equals, my first equation, is going to be 400 minus 75. Close that off. E raised to the negative 0.0735 x instead of t plus 75. All right. The next one is going to be 450 minus 75. We still got our e, but that's going to be raised to the negative 0.0817 x instead of t plus 75. All right, I got it in there, right? Now look at the first hoodie, or excuse me, the hoodie was 450 degrees to start. So my y, which represents time, I'm going to have to at least go to 450. So on my window, okay, my x's, let's start at 0, because x is time. And let's go to, I don't know, 25 minutes. Okay, we can change that later. We'll go by 5s. But my temperature is never going to get to 0. Let's start it at 500 and change my scale by 100, because I don't want to see 500 tick marks. I want to see 5 tick marks, one at each of the 100, at 100, one at 200, 300, and so forth. I'm going to graph these. Okay, the blue is my t-shirt. Okay, there it is. It's cooling down because it's going down as time goes. And the hoodie, which started up higher at 450, right, is coming down and it intersects right there. Look at that. Would you look at that? Something right there. So it's whatever minute x value this is. So I'm going to do the intersection. Second trace. Then I'm going to go to intersect. And I'm just going to hit enter 3 times. 1, 2, 3. And that's at roughly 17.451. It says at t is approximately 17.451. They want that to the nearest minute. That will say 17 minutes. So about 17 minutes. Now, if you're the type of person you're like, but I'm freaked out because I'm not showing work. Well, I mean, if you want to, okay, we can graph them both. Something like this, bang. Something like this comes, it's a little bit higher, bang. And this happens right here when t is approximately 17.451. Okay, I mean, you can graph them both like that if you want. That's not a problem at all. You're good to go. We're good to go. We slayed this test. There's a huge curve on here, so you might have actually did really good at this test. Good luck.
Don't forget to subscribe and ring that bell.